Hello, welcome to this PC tutorial, and today we're talking on correlation analysis. If this is the first time coming across this channel will make mathematics, statistics, and physics easy. So you're free to click on the subscribe button and join the learning community. In this particular video, I'm going to explain what correlation analysis is. I'm going to explain what a positive correlation is and a negative correlation. I also explain the difference between the Spearman's correlation coefficient and the Pearson's correlation coefficient, and not the one to use in solving a problem. So stay to the end of the video to get the full gist. Let's get to the video. So now, what is correlation? Correlation can be defined as a measure that indicates the extent to which two or more variables fluctuate together. And we have a positive correlation and a negative correlation. A positive correlation is one in which the variables move in the same direction, meaning if the x variable is moving up, the y variable is also moving up. Or you can say if the x variable is increasing, the y variable is also increasing. So this is the x variable and this is a y variable. While for a negative correlation, the variable is moving opposite direction, meaning if your x variable is decreasing, your y variable is increasing, and vice versa. So now, from the beginning of this video, I told you I will explain the Pearson's correlation coefficient and the Spearman's correlation coefficient. So now let's do that now. In solving a correlation problem, you observe first to know the particular one to use, either Pearson or Spearman. Pearson is when the x and y variable is when there is no rank. So let's write it Pearson coefficient, Pearson correlation coefficient. The Pearson's correlation coefficient is for unranked data. So this is for unranked data. Unranked data. Why the Spearman's correlation coefficient is for ranked data. So the Pearson's correlation coefficient is for unranked data. Why the Spearman's correlation coefficient is for ranked data? Ranked data means if they give a data now, they'll be like this guy is first position, second position, third position in form of ranking, or first grade, second grade, third grade. That's what rank data is all about. Now, let me give you the general formula for a Pearson correlation coefficient and a Spearman's correlation coefficient. Then we can go over and solve an example to understand this better. Now, this is the general formula for the Pearson's correlation coefficient. Or let me write it here. For your Pearson's correlation coefficient, this is the general formula. R equals to summation x minus x bar times y minus y bar all over square root of summation x minus x bar square times summation y minus y bar square. This is the general formula for your Pearson's correlation coefficient. In all my videos, I always explain what the parameter stands for. X bar stands for the mean of the x variable. Y bar stands for the mean of the y variable. Now, for your Spearman's correlation coefficient, the general formula is R equals to 1 minus 6 summation d square all over n bracket n square minus 1, where n stands for the number of observation and d stands for the difference between the two ranks. And now, let's solve an example on the correlation analysis to understand better. So now we have a question here. Let's solve it together. Question says A study is conducted involving 4 students to investigate the association between statistics and science tests. The first data given is our x variable and the second one is our y variable. The question arises here is a relationship between the degrees gained by the 4 students. And this data they gave us. Students 1, 2, 3, 4, statistics, which is our x variable, 10, 13, 8, and 9, science, which is our y variable, 20, 25, 11, and 24. First thing to do is to identify if it's a Pearson correlation coefficient or a Spearman's correlation coefficient. And from this question, there was no ranking. So it's obviously a Pearson's correlation coefficient. So we use the formula for a Pearson correlation coefficient. And what is the formula? R equals to summation x minus x bar y minus y bar all over summation x minus x bar all squared times summation y minus y bar all squared. So this is our general formula for a Pearson's correlation coefficient. Now let's bring out our table now. So our table will include x, y, x minus x bar, and y minus y bar. Then it will also include x minus x bar times y minus y bar, x minus x bar square, and finally y minus y bar squared. So let's bring that our tables together. So sorry for the discontinuity in the video. I want to make enough space for my table of values. So our first column will be our x. We have our y. It's not that long. Let us make it short. What is next? X minus x bar. X minus x bar. We have y minus y bar. We have x minus x bar times y minus y bar according to our formula. And oops, let me bring it down here. We have x minus x bar all squared, and we have y minus y bar all squared. So this is our table of values. Our x variable, our y variable, our x minus x bar, y minus y bar. So we can multiply them together. This times this to give you this other column. From the denominator, we have the summation of x minus x bar square. So we brought out a column for x minus x bar square and y minus y bar squared. Now, what is our x bar? What is our x variable? The first data, which is statistics. So it's 10, 13, 8, and 9. Our y, the second one, which is science, 20, 25, 11, and 24. Now, our x bar, for what I said earlier, x bar is the mean for the x variable and y bar is the mean for the y variable. So to get our x bar is summation of your x, which is summation of your data all over the number of data. So summation of x all over n, which is equals to 10 plus 13 plus 8 plus 9 all over 4, which is equals to 10. And to get your y bar is equals to summation of your y variable all over n, which is equals to 20 plus 25 plus 11 plus 24 all over 4. Upon this, you get 20. So this is your y, your x variable, and this is your y. Sorry, this is your x bar and this is your y bar. Now let's fill our table. So this is x minus x bar, which is 10 minus 10. So here is 0. Next one, x 13 minus x bar. So 13 minus 10, here is 3. 8 minus 10 minus 2. 9 minus 10 minus 1. The next column, y minus y bar. So 20 minus 20, 0. 25 minus 20, 5. 11 minus 20, minus 9. 24 minus 20, 4. Now, x minus x bar times y minus y bar. So, 0 times 0, 0. 3 times 5, 15. Minus 2 times minus 9, 18. Minus 4 times 4, minus 4. Sorry, minus 1 times 4, minus 4. Now we have our x minus x bar squared, meaning we'll square this column. We'll square our x minus x bar column. So 0 square is 0, 3 square, 9, minus 2 square, 4, minus 1 square, 1. And last but not the least, our y minus y bar square. So we'll square our y minus y bar column. 0 square, 0, 5 square, 25, minus 9 square, 81, and finally 4 square, 16. So now I've brought out our table of values. Now let's put it inside our Pearson's correlation coefficient formula and get our final answer. So this is our formula here. From our formula here, summation x minus x bar times y minus y bar. So you come to a table. What are we summing? X minus x bar times y minus y bar. So you sum this guy. If you sum it, what do we have? 0 plus 15, 0 plus 15 plus 18 minus 4. You have here 29. You go to the next one. We have summation x minus x bar square. So you come. Summation x minus x bar square is here. You sum it. That is 0 plus 9 plus 4 plus 1. Here is 14. And finally, we have summation y minus y bar square. You come here and you sum it, which is 0 plus 25 plus 81 plus 16. That is 1, 2, 2. So you put it in your formula here. The numerator is what? Summation x minus x bar times y minus y bar. So numerator is 29 all over square root of, this is summation x minus x bar square, which is here 14 times summation y minus y bar square, which is here 122. If you put this in your calculator, you have 0.70. So this is your final answer. This is how you tackle any correlation problem using your Pearson's correlation coefficient. You break out your table first. After you brought out the table, including x minus x bar, y minus y bar, x minus x bar times y minus y bar, x minus x bar square, and y minus y bar square, you sum the necessary ones. You can sum the rest if you want, but it's not important. The important thing is to sum the one needed in the formula. Once you sum them, you put it in your formula and get the final answer. So this video was helpful for you. I know you learned something. Please, you can subscribe to the channel to get notified when I drop a new video. And most importantly, like the video so it can be pushed to others so they can learn too. Thank you and see you on my next video. Bye.